Welcome to our first section, Introduction to JMS and MDBs. Java Message Service, or JMS, is a powerful tool in Java EE. It enables applications to communicate asynchronously using messages. This messaging model offers flexibility, allowing systems to exchange information without direct coupling. JMS operates on a provider-based approach, meaning you need a JMS provider to handle message queuing. Message-driven beans, or MDBs, are a key part of JMS. These are enterprise Java beans, EJBs, designed to process messages asynchronously. They listen on specific destinations, and when a message arrives, the MDB receives it and executes business logic. This setup simplifies development, as developers can focus on processing logic without handling message infrastructure details. MDBs are particularly good at handling time-consuming tasks. For example, imagine an e-commerce application where an order is placed. An MDB can handle order processing, inventory updates, and email notifications, all happening in the background, allowing the application to remain responsive to users. Now let's dive into Section 2, Understanding JMS Messages, Producers, Consumers, and Destinations. JMS revolves around a few key concepts: messages, producers, consumers, and destinations. Messages are the information packets exchanged between applications, containing data and metadata that guide their processing. Producers create and send these messages, placing them on specific destinations. Consumers, on the other hand, receive and process messages from these destinations. Destinations act as the endpoints for messages. There are two main types of destinations: queues and topics. Queues implement a point-to-point messaging model where each message in a queue is processed by a single consumer. Topics, in contrast, support a publish-subscribe model where messages sent to a topic are delivered to all subscribers. JMS offers flexibility through these concepts. Applications can choose the most appropriate messaging model, define custom message types, and even integrate with various JMS providers. This makes JMS a versatile tool for building robust, loosely coupled systems. Moving on to Section 3, Message-Driven Beans, Asynchronous Messaging Powerhouse. Message-driven beans, or MDBs, are the workhorses of asynchronous messaging in Java EE. They are specialized EJBs designed to seamlessly handle message-driven tasks. Unlike other EJB types, MDBs don't have a remote or local interface. They interact solely through messages, receiving them from destinations and processing them asynchronously. The beauty of MDBs lies in their ability to decouple message processing from the main application flow. This is crucial for tasks that might be time-consuming. Imagine an image processing application where a user uploads an image. An MDB can be triggered, performing tasks like resizing, watermarking, or applying filters, all in the background, without affecting the user experience. MDBs also excel in handling event-driven architectures. They can listen for specific events, such as database updates or system notifications. Upon receiving an event message, the MDB can initiate appropriate actions, like sending alerts or updating other systems. This event-driven approach promotes loose coupling and enhances system flexibility. Deployment descriptors play a vital role in customizing how message-driven beans, or MDBs, are deployed and function within a Java EE application. These descriptors are XML files that provide configuration details the application server uses to manage the MDB's lifecycle and interactions with the JMS provider. One of the key pieces of information specified in the deployment descriptor is the MDB's connection factory, which is responsible for establishing connections with the JMS provider. It ensures that the MDB can send and receive messages. The deployment descriptor also defines the destination type, queue or topic, and the name of the destination that the MDB will listen on. Additionally, the deployment descriptor allows you to configure other aspects of the MDB's behavior, such as transaction management, security settings, and resource references. This fine-grained control makes deployment descriptors an essential tool for managing MDBs effectively within a Java EE environment. Java Message Service, or JMS, provides a robust mechanism for asynchronous communication between applications. Message-driven beans, MDBs, act as the engines that power this asynchronous messaging, enabling efficient handling of time-consuming or event-driven tasks. Deployment descriptors, through their XML-based configuration, provide the necessary instructions to the application server for managing MDB deployment and behavior. Together, these elements, JMS, MDBs, and deployment descriptors, form a powerful trio in the Java EE ecosystem. They allow developers to build loosely coupled, scalable, and responsive applications. JMS enables asynchronous messaging, providing flexibility and decoupling. MDBs handle message processing efficiently, offloading tasks from the main application flow. Deployment descriptors ensure that MDBs are configured correctly and integrated seamlessly within the application server environment. Understanding these concepts is key for any Java EE developer looking to leverage the power of asynchronous messaging. By mastering JMS, MDBs, and deployment descriptors, you can create applications that are not only robust and efficient, but also adaptable to changing business needs and evolving technological landscapes.